Hi class, this is Mrs. Albritton. We're going to continue factoring polynomials using the greatest common factor. In part one, we focused solely on just finding the GCF of monomials. In part two, we're going to use those GCFs so that we can factor polynomial expressions. So I'm going to go back through the I do and the we do sections. If you have not already worked on your you do section, make sure you get that done. Let's start with number one. We're going to factor 6x squared minus 24x. And we're going to use the greatest common factor if they have one. Keep in mind that sometimes they may not have a greatest common factor that you can use. The GCF of 6x squared and 24x is going to be 6x. The greatest common factor of the numbers is 6, and the greatest common factor of the variables is x. So the setup is to move the greatest common factor to the outside, and then the remaining information will be on the inside. What I mean by that is if 6x is my greatest common factor, then I need to divide out 6x from 6x squared. So if I pull 6x out of 6x squared, there's just an x left. Minus, if I pull a 6x out of 24x, well, let's start with the numbers. If I divide a 6 from 24, that leaves 4, because 6 times 4 is 24. And if I pull an x out of x, there's no x left. So there's my answer. I can actually check this to see if the answer is right, because if I take the answer I got and multiply it, I should get this original problem back. I can use distributive property to multiply 6x times x. That equals 6x squared. And 6x times 4 is 24x. And since I did get this original problem back, I know that my answer is correct. Let's do number 2. The GCF of 14x squared and 35x is going to be 7x. So I'm going to pull 7x to the outside, and I'm going to have parentheses with the remaining factors on the inside. So if I pull a 7x out of 14x squared, let's start with the numbers. 7 divides 14 twice. X squared leaves an x. Minus, if I pull a 7x out of 35x, there's a 5 left. Again, I can check this by using distributive property and multiplying this factor times this factor. So 7x times 2x is 14x squared. Minus 7x times 5 is 35x. And again, I get the original problem, so I know I'm correct. Number 3, the GCF of 5x squared plus x. Well, remember, there's a 1. If you don't see a number in front of a variable, you know the coefficient is going to be 1. So I'm looking at the GCF of the numbers 5 and 1, and they only have a 1 in common. But the x squared and the x have an x in common. So I'm going to pull, and remember, I don't really need the 1 there. So I'm going to pull an x out to the front. So if I pull an x out of 5x squared, I have a 5 and an x left. Plus, if I pull an x out of x, it's just a 1 left, because remember, I can write it as 1x. I can check this by doing x times 5x, that's 5x squared, plus x times 1 is x. And see, I've got the exact same answer right back, so I know that I did it correctly. Easy way to check your answer. Number 4, we're going to go a little quickly so we can get through these. My GCF of this one. Now let's look at this, because we've got quite a bit going on. So 2x to the 4th y squared plus 15x cubed y cubed. When I look at the numbers 2 and 15, they don't have anything in common. But of course, 1 can be placed there because every number has 1 as a factor. So if you don't see anything, obviously, then it's going to be 1. Now, x to the 4th and x to the 3rd. So x to the 4th is 4x's. X to the 3rd is only 3x's, and they're all being multiplied together. So in common, they have those 3x's. So x to the 3rd. Y squared and y third has y squared in common. Again, I don't need the 1 in front. So what am I going to pull out to the front? The greatest common factor, the x cubed, y squared. And then what's left goes in the parentheses. So let's see. If I pull out an x cubed, well, the 2 is going to be there because there's no number that was pulled out. So that stays. But if I pull an x cubed out of x to the 4th, 1x is still there. Because that's 3 x's, that's 4 of them. And I only pull those 3 out, so 1 is left. If I pull a y squared out of y squared, there's no more y's left. Does that make sense? Ask questions when you come back to class if you need to. Now let's go to the next one. So again, the 15 is still there because I didn't pull any numbers out. There's no numbers in the greatest common factor other than 1. And if I pull a 1 out of 15, 1 divided by 15 is just 15. But let's go to the variable x squared. So if I pull an x cubed out of x cubed, there's no more x's left. And then y squared out of y cubed will leave a y. And this one's kind of tricky, so you got to be careful. And again, I can actually multiply this factor times this factor, and I should get that same information back, this same answer. Let's get this one. The GCF. Let's look at the numbers first, 17 and 51. And even though 17 is a prime number, it is a factor of 51 because 3 times 17 is 51. That means they have a 17 in common. And then x squared and x, all they have in common is an x. That means the GCF is 17x. It comes out front. And then I see what's left. So if I pull or divide a 17x out of 17x squared, there's an x left. Plus, if I take a 17 out of 51, 17 divides 51 3 times because 17 times 3 is 51. And then pull an x from the x, there's no x left. So there's your answer for number 5. Number 6, the greatest common factor. 36, 63, and 27. So those 3 numbers all have a 9 as their largest common factor. Now let's look at the variables. X cubed, x squared, and x. There's only one x that all 3 of them have in common. Therefore, our GCF is 9x. Now, when I pull a 9x out of 36, x cubed, let's start with the 9. 9 divides 36 4 times. X divides x. Well, x being pulled out of x cubed will leave x squared. Plus 9 divides 63 7 times. And pull an x out of x squared. There's only one x left. Minus 9 divides 27 3 times. Pull an x from that x, and there's no x's left. So our answer will be 9x times 4x squared plus 7x minus 3. And again, you can check each of these answers to verify that they're right by multiplying them using the distributive property. Make sure you work on the you do section. Bring answers back to class.